Okay, let's talk about quadratic functions. So quadratic functions, when graphed, will give you parabolas. Each parabola will have either a maximum or a minimum value. It will not have both. Okay, so think about if the parabola goes up, then we're going to have a minimum value, and if the parabola goes down, then we're going to have a maximum value. And that's kind of what this is saying in this box here. So we've got a quadratic function, f of x equals ax squared plus bx plus c. And then we're going to determine the axis of symmetry of this parabola by doing this negative b over 2a. And then it's saying if a, not the value of the axis of symmetry, but if a is positive, okay, so that's our leading coefficient there for our quadratic. If that thing is positive, then it has a minimum value. And the minimum value is whatever I get when I plug in my axis of symmetry into the function. Okay, so if a is positive, I'm going to know that the parabola is going up, which means we have a minimum value, and it's going to be whatever the value is when I plug my axis of symmetry back into the function. If a is negative, that leading coefficient is negative, the graph will go down, and we then have a maximum value at that location instead of a minimum value. So to find the maximum values, what we're going to do is we're going to find the axis of symmetry, and then we're going to plug it in, and we are going to figure out, does the parabola go up or does it go down? We can figure that out right away so that we know if we have a maximum or a minimum. All right, so I'm going to do axis of symmetry here. So it's going to be negative b, which is the number in front of x, over 2 times a, which is the number in front of x squared, which would be 1. So negative 4 divided by 2, that's going to give us negative 2. Now again, that's the axis of symmetry. So this parabola is going to be centered about the x value of negative 2. But I want to figure out what the axis of symmetry, or sorry, what the vertex or the maximum value is going to be. So I'm going to plug that back in. So I'm going to do f of negative 2, and that's going to be negative 2 squared plus 4 times negative 2. Which would be 4 minus 8, which is going to be negative 4. So that y value, that is going to be your max or min value. And because this is a positive 1x, this means this parabola goes up, which means this is a minimum value. Okay, so I have a minimum value, and it occurs at negative 4. The minimum value is negative 4. Number 2, again, axis of symmetry, so x equals negative 4 over 2 times a, which is negative 2. So we'd get negative 4 over negative 4, which would be positive 1. So then I just need to do g of 1, which is going to be negative 2 times 1 squared plus 4 times 1 minus 5, which would give us negative 2 plus 4 minus 5, which is going to be negative 3. So that, negative 3, is going to be my maximum value. And this time it's going to be a maximum because a is negative. That means my parabola is going down. So then I'm going to have a maximum value at the very top, and that maximum value is negative 3. When we graph quadratic functions, we've got a couple different forms here. First of all, we have standard form, which is kind of what we've just been looking at. Ax squared plus bx plus c. The way that you would graph this is you would have an axis of symmetry. So for example, if I were graphing this first one here, x squared plus 4x, I would have an axis of symmetry at negative 2 here. Okay, so at negative 2, I know that my parabola is going to go right around that. We actually figured out the vertex of this thing, which was at negative 2, comma negative 4. So that's what that tells you. Axis of symmetry is the x equals negative b over 2a. And then if that's going to give me my vertex. And then because this goes up, I know that I'm going to have a parabola that does this. Okay. This other form is vertex form, which is kind of nice. All I need to know is that h comma k is my vertex. And so I have this vertex, h comma k. So if I know what the vertex is, or it's in vertex form, all I'm going to do is go to wherever that vertex could be. based on what those numbers are, where that's going to be h comma k, and then that would determine where my parabola is, where its maximum location is. Okay, so a couple different forms there. It's actually easier to graph if it's in vertex form. So we are going to take some parabolas, some quadratic functions that are written in standard form, and we're going to convert those to vertex form. Okay, and then what we're going to do is find the maximum value from that. So by the end of this, you're going to have a couple ways to find the maximum value. One is to do this x equals negative b over 2a and plug it back in. The other is going to be to convert this to vertex form, and then we'll be able to figure out what that maximum value is. So we are going to do what's called completing the square. And so we are going to group our x terms together, and then we're going to put the plus 23 out to the side. We are also then going to factor out the coefficient that's in front of our x squared just from those x terms and keep that plus 23 out to the side. Then what we're going to be looking for is, what can I add in here? What can I add in here to make this thing inside be a perfect square trinomial? And what that means is it factors as the same thing twice. And the way that we're going to figure that out is we're going to take this middle value, which is negative 6. We're going to divide that by 2, and we're going to square it. That's the process here. So negative 6 divided by 2 is negative 3. Squared is going to be 9. Now, I can't just like add in a value into my function and just leave it there. So I have to like compensate so I'm not changing the value of this expression or this equation. So I'm going to, really what I added in when I added this plus 9 right here is I added in a 2 times 9 because I have this 2 out front. So I'm at the end going to subtract 2 times 9 so that I get rid of that same value that I'm adding in there. Okay, and then by doing all of that, we can then go straight to the answer. So f of x is going to equal, I'm going to have that a value of 2 out front. Now we said, why did we put that plus 9? We did that so that this thing right here factors as the same factor twice. So what multiplies to 9 and adds to negative 6? That's going to be x minus 3. And then I've got to figure out what all this is going to give me out to the outside. So I've got 23 minus 2 times 9. 2 times 9 is 18. 23 minus 18 is 5. So that's going to be plus 5. And this is the same thing as this, just in vertex form instead of standard form. Now when it's in vertex form, I know what the vertex is. Okay, the vertex is going to be at 3, 5. So you kind of just do like opposite of what's here and the same as what's here. But you should then know that the y-coordinate of the vertex is your maximum value, and therefore we have a minimum value of 5. And why is it a minimum? Because my a value is 2, which means my parabola is has got a positive a value, so it goes up, and therefore my vertex is at the bottom, giving us a minimum value of 5. Okay.